The focus of this video is going to be our Hole Wizard found up top within our Features command ribbon. What this command is going to do is this is going to allow us to draw holes in a much faster way that is going to be better connected to actual hole sizes, actual drill bit sizes, threading, anything like that. And it's going to make it a little bit easier for us in the long run for dimensioning and other pieces like that. So if we take our Hole Wizard here, there are a ton of options that we can talk about with it. And I'm just going to start by saying I will not be going through every single one of them. I'm going to talk about what I think is the most important and a little bit more versatile aspects of it. And there's a lot of pieces that we could talk about that are customizable, but I think most of what is being skipped is stuff that we've already somewhat covered within our extrudes and our extruded cuts, or pieces that we don't really need to cover because you could really just play with it a little bit and figure out what those features are going to do pretty easily on your own. With that, let's get started. When I open my Hole Wizard, we have 9 different options for what hole type we want to make. And I'm going to focus today just on this little, that's a terrible line, just on this little Tetris piece up top of these 4. So with this, these are kind of the basic ones that I think are particularly useful. The bottom 3 that we're not going to look at all are slots, and then the 2 above it that we're not going to look at are really just more customizable, a little bit less connected versions of aspects that we could do above. So the 4 that we're looking at are really focused on what materials you might actually use to make these holes. Now, the first thing we're going to do when we're in this, other than selecting our hole type, so I'm going to go ahead and start by selecting my most basic hole right here. This is just a drilled hole straight in. We're not using any funky features, countersinks or counter bores, and we're not adding any threading to it. Once we have this selected, we have a couple of drop-down menus right here. And these drop-down menus tell us what category, what type of threads we're looking for using in our part. Once we have this set, we're unlikely to use multiple different pieces. You're normally going to use a standard set of drill bits. You're not going to be jumping between different sets for a lot of projects. But we set our drill bit type that we want to use. Basically what this is doing is, if you think about actual drill bits, you're giving it what case you want to work with. So you've got a bunch of cases with a bunch of different drill bits in it. And this is just, you want to go to this container to find this drill bit. After that, once we have that selected, we can go down and we can select our actual drill bit. So you're seeing all of these labels right here, and all of these guys are just the different labels, the different individual drill bits that we could actually use. So within this is just what, if you wanted to find the drill bit, you would buy what you would actually look for labeled on the drill bit as far as their size and what hole you want to cut. So we can select any one of these, and we're going to go ahead and add this hole. I've got it set to through all. So the next piece I need to do is I need to talk about where I'm going to position the hole. So within positions, we have the ability to select any location on the face that we want to be cutting into. And I'm not going to show in this video, but you can select multiple if you want to cut a bunch of the same hole at the same time. And once we have this position selected, we can continue to go back and forth between type and position. Once we've gone to the one, it doesn't mean we can't go back. But what this is going to do is this is going to go ahead and set where we're cutting into. So I'm just going to go ahead and select a location here, and I have cut into my face. I've set it to a through all hole, and it's actually created a sketch right here that SolidWorks has used to cut the hole. That sketch is something we're going to talk about in a couple seconds here. So with this, I have the ability to do anything as far as cutting my hole, just like I did in SolidWorks before when I had extruded cuts. So I've just switched it to blind. So I want a blind cut, meaning I'm cutting a certain distance in. And it is a blind cut. I had it through all before. Basically anything we could do before with our extruded cuts, we can do with our hole wizard here. So I've selected how I want this guy to be set up, and I just set it to a blind 2-inch cut, so that now if I look at my piece, it is created a 2-inch cut. Now, first thing we're going to notice here in this section view is this is not just an extruded cut, because we have this little feature down here at the bottom. This is because you're probably cutting this with a drill bit. And if you're cutting with a drill bit, not a mill bit, which would be a mostly inappropriate way to do this, you're going to have this little diagonal piece at the bottom, this little cone at the bottom, that is going to basically be the leftover as your bit is cutting in order to reduce heat and actually break less tool bits. You're going to have it cut a little bit deeper than just a perfect cylinder. So it automatically adds that to our part. Now the other thing we're noticing with this, if I drop this down, I have 2 sketches. This bottom sketch right here, which is highlighted, but you can't see it as well as we could a little bit earlier in the video when I circled it before. That sketch is the sketch used to revolve and cut this hole. And then this sketch right here is our second sketch, and this is our underdefined sketch, which shows us we have some problem going on here. Ideally, we have everything within our SolidWorks model defined. And what this sketch is this sketch is our position. So remember, we just kind of selected somewhere in order to say where our hole was, or our holes were if we had multiple of them. And that point was just where I clicked on a face. We want to have this locked down somehow. So we can always go back and we can add this, or we could pre-create a sketch with lines that we could use to then click on and figure out where our piece is. If I wanted it here truly, I could go ahead and add a couple of dimensions so that I have it locked into a known location. For instance, in this case, my origin point, I could also have it dimensioned from my edges here if I wanted to locate it that way, because those are, again, known positions. But it means that my hole can only be in one place instead of potentially a movable hole, which is not what we want. In this case, what I'm going to do is I'm just going to go ahead and lock it to the origin so that it has a fixed location. We know where it is, so I'm just going to click on it and I'm going to drag it over to the origin. And when I exit out of my sketch here, I'm going to go ahead and refresh SolidWorks, and you see instantly here, this sketch is no longer underdefined, so we have fixed that problem within SolidWorks. Okay, moving on a little bit. I'm going to go ahead and show these things within our section view just to make it a little bit easier to demonstrate what's going on. But we're going to go in and we're going to edit this feature, and we're going to start talking about a couple of these other options. So the 2 that I'm going to talk about here, I'm only going to show one of them, but we have our countersink and our counter bore, depending on whether our screw has a top that looks like so, or maybe like a button head or a flat head, where we're going to want the counter bore such that basically this is allowing it so when our screw goes in, it is going to sit level with our overall object that we're screwing our screw into. So with this, we can select either of these, and they're going to have options for how to dimension, how to define our counter sink or counter bore. I am showing a counter sink here. I've got my diagonal line. It added that no problem. Couple pieces that we can add there. So there's the counter bore. And with this, it'll normally automatically select what's recommended based off of your hole size immediately for you. Next piece we're going to talk about is we're going to go ahead and talk about our threaded holes. I jumped gun a little bit there. Let me get back to, there we go. We've got our threaded holes. So what this is doing is we're actually noticing that some of this changed, because this is now defining based off our threading, not just our screw that's going in, but we can still customize a number of pieces within this. So this is our only option of these 9 options that is going to add threading. And I have created a threaded hole. Now it's not actually modeling the threading. We don't actually see the winding pieces for the thread of the hole. That is because that would be a great way to have SolidWorks crash even more often on you, especially since we're working a lot on our laptops still. So with that, this is just storing the information and making sure we know it's that threading and setting our hole up for that. So this is creating a tapped hole, as we can see here. And if I go into it, I have the ability to change that tap. I'm going to go ahead and run with 1/4-20, even though I've got all these options. I have the option to change the distance that I'm actually cutting this hole in, and I have the distance that I'm actually going to run my tap. So a lot of the times, especially with wood screws, you're probably not going to run the tap very far or at all. And even with metal, you don't necessarily run the tap the entire way. You really can't do it exactly the entire way in a lot of cases, but we can show that information there as well. Now, seeing as this is the only place this is available, we can actually add pieces, such as adding this countersink to our threaded hole. So we don't have to worry about the fact that there wasn't an option. I'd have to scroll up, but up here, we're seeing the very bottom of it right there. We had the countersink option and the counterbore option before. We can actually go ahead and we can add a countersink or counterbore to this without having to deal with the fact that we're not using the countersink option. So we can actually set our own countersink up. I go ahead and change it to a large enough piece that we can see, but we have that countersink added here. And now we have created this entire hole, even though it's not shown in that piece above. Okay, not going to talk about anything more here. So with this, in a second here, might have to jump up. Okay, we're going to jump forward a little bit. This is really going back to talking about the different types of pieces we could do. Again, this tapering, this just like within our different, looking at the different classifications and different boxes we can do for the drill bits, we can look in the different boxes for our taps and everything as well. So this is just all these 2 categories are doing up here are setting what you can see in this category below. Okay. Let's jump forward a little bit here. Now, why we're doing it like this, and the really real advantage to this is in order to work with our hole callout. So our hole callout piece is a command up top that I can work with. This is like super smart dimensions for holes. And what this guy is going to do is this guy is going to allow us to add a single dimension right here that has a ton of information about my piece for me. Oop, that is a pretty bad circle. Sorry about that. So I have everything about my hole right here. I have a 0.2 inch diameter hole that is cut 0.65 inches down into the material. And then I am running a 1/4-20 tap that I'm running down 1/2 inch into the hole. And then at the very top, I have a taper. So I've got that symbol right there, this guy, that I'm adding. I'm adding a counter sink that is going to be a 90-degree countersink on the near side of the hole. If I was going all the way through, I might have one on the far side. But that is defining this hole entirely for me. And that means that I don't have to figure out how to create a section view in order to add all of this definition. But as we can see, if we were to add all of this, and I go ahead and I show hidden lines, again, remember, well, we'll be talking shortly about how we don't dimension to hidden lines. But if I go through, I can add a couple dimensions here, and I am seeing that I am indeed 1/2 inch down for my threading. I am indeed cutting, I'm indeed cutting down 0.65, and I have a 90-degree taper. I think the first time I do this, I grab 45 degrees for 1/2. Yep, I grab 45 degrees. But got 45 degrees or 90 degrees, I'll do in a second, showing between the two. And I could add all of this information, but it is a whole lot easier, because this isn't even an appropriate way to do this. A whole lot easier to do it within my Hole Wizard command, because everything is just there, and I've created all of this extra information that would have to take me multiple different commands otherwise to do. So again, fully dimensioning it, I'd still have to go back and I would have to tell myself where this hole was. I need to have a dimension here and a dimension here to show that I'm fully defined. But I have saved myself a lot of work, and I've kept a ton of extra information all in one place for myself to make my job a lot easier. So that is really the highlights of the Hole Wizard. I hope that is helpful to you. Take care.